Yeah, hello everyone, welcome to Yourpedia Education. So basically, as you know, the BEL also released the notification. I already make a video of that one, that which subject has how much weightage. Today I come with one topic, that name is what dual-well process or twin tube process. Basically, whenever you are making a CMOS, right, in CMOS we are having two things, the PMOS and NMOS, right, and this is the process how you can make the CMOS on a single structure. That's why its name is dual-well process, right? So as this topic is having most, and you can say the more and more importance, because last time in the exam of May exam, basically the BL asked almost 4 to 5 questions from this topic. One more thing, if you want to prepare for BL, you have to be more focused on such type of topics. Why? Basically, if I am talking about, there are around 100 questions for a technical part, from your technical part, I can say 100 questions from your technical part, and out of these 100 questions you have to be score 80 marks, right? 20 is the gap if you want to be you can say that at the secure positions, right? And out of 25 you should secure 20 marks in that aptitude part also, right? So basically, if you want to get a secure place in that one, you need to be score 80 marks in that one. So rest of the topic which you studied inside your gate and other, when you are preparing for other exam, right, you are not studying these topics, the fabrications, the fabrication of diode, fabrication of NMOS, PMOS and CMOS, right? So today we are going to discuss the fabrication of CMOS. These are the really important topic. They are playing a crucial role in your selection, right? There are several topics, right? You can't focus only on the technical part which you studied in the gate, but the BL exam is little bit different from the gate exam. As of you know that here the questions are coming not that much depth, that much in the gate exam. The questions are you can say based on the basics of each and everything, but there are means you can say the wide of things you have to cover for this exam. Like this is the topic where we see 3 to 4 questions. And one more thing, what I see in that one, that first question from this one, then second question is also from this one, which is you can say almost related to that one, just a smaller changes. I see this type of questions, several questions are there, this type of. So if you want to prepare for this BL, you can't leave these type of topics. So today it is an important topic I am going to discuss with you, that is dual-well process and twin tube process. This is the process to make a CMOS inverter on a single chip, right? So first what we have a substrate, right? If you are making PMOS and NMOS on a substrate, we generally choose a P-type substrate. On the P-type substrate, right, we grow a oxide, right? Oxide means what? SiO2 layer. Generally, we grow a SiO2 layer. So what we can do? First, you are having a substrate, right? Substrate is P-type. Generally, we make a P-type substrate by using ionic implantation. So now we start with P-type substrate. On the P-type substrate, you are decomposing or you are doing the oxide layer. You grow a oxide layer here, right? On that growing oxide and that oxide layer, this is oxide layer will be performed like a insulator. It will be work like a insulator, right? So this SiO2 layer, above this SiO2 layer, we are doing or we are growing a layer of Si3N4 silicon nitrate. That process with the help of chemical vapor deposited, means we are depositing Si3N4, right, by using the method that is called CVD, chemically vapor decomposited on the top. So what we are doing, we just make this you can say what is the main purpose of providing this S3N4 layer? The pad oxide causes the silicon from the stress of the nitrate layer. The nitrate layer is a barrier for oxidation, so that the further oxidation will not perform on the silicon wafer. So for that one we make a layer of silicon nitride on that semiconductor, right? Or you can say the on above this SiO2 layer. So well definition, the photo lithography for N wall and P walls. So basically what is the final structure here? Let me show you that one. Finally we are at the end, we are getting, one second, these all the structures, yeah, finally we are getting like this structure. This is N wall, this is P wall here, right? And we are having, this is, because it is N type, so we are having N channel. This is called N channel, this is called P channel, right? So we are having two types of P channel or N channel. You can say NMOS or PMOS on the single substrate. So to make this complete structure, what we do? First we do oxidation. After oxidation we provide a layer of silicon nitride to get that thing, right? Okay, yeah, this one done. Now after that what we do? P wall masking. We do the P wall and N wall masking, right? A layer of photoresist, above that one a layer of photoresist is applied and pattern using P wall mask. This mask expose only the areas where the P wall for NMOS transistor should be, right? Where you want to P wall means where you want to build a NMOS transistor, you have to do the masking above that, right? We do the masking here. After silver nitrate we do the masking. We do the masking where we want the N wall or P wall, like this. We do this masking. This part is called as masking. After doing the masking, here we do the masking, here we do the masking of photoresist, right? Yeah, a layer of photoresist, and same thing the process is repeated for N wall also. We are providing that masking for N wall also, right? So that we are having a selected region, open window, right, in the nitrate or oxide select subsequent well implant, so that we can implant the doping inside that one, right? Wall implantation, how we can do that? Where you place the P mask, right? We place the P mask and rest of the things are removed. We place the P mask here and rest of the part we remove. This part we also remove, this part we also remove. We left with this one. So these are the two walls, this one and this one. We get this portion and this portion, right? We remove rest of the parts. We are having two walls like this, right? So after doing this, right, within the P wall, which one you want a P wall, another one we want a N wall, right? The P wall mask is placed and boron P type dopant is implanted into the exposed silicon region, right? The silicon region which is exposing here, we are doing the implantation inside that one, means we are doing the doping inside that one. That doping is for P wall we are having boron type or P type dopant, and for N wall we are having the phosphorus or N type dopant. We implant that one inside this you can say the walls, right? After wall driving. So after doing this, the wafer is subjected to a high temperature. Why we are putting it at high temperature? So that the dopant which you inserted inside that one, they will you can say move deeper inside the semiconductor, right? And the uniform doping, or you can say the doping profile become uniform for that one. After doing that, we remove the nitride and pad oxide from there, so that we will got the SiO2 layer, right, by chemical etching. This etching process is called as removing this nitride or pad oxide from that one. Isolation and gate formation. Isolation means whenever you are having two semiconductor, you have to be you are having two devices, you have to be provide the isolation between them. The wafer is placed in a high temperature oxidation furnace. The thickness layer of SiO2 is called as field oxide and grow on the area not protected by the nitride, right? Nitride mask, where you remove the nitride marks, it will be doing that, making a oxide layer. Right? This oxide electrically isolated and adjusts the transistor from one another. So main thing is that what we do the isolation, we are making a separation between these two. So what we do, we do the oxidation so that the two devices are separated from each other, right? And the oxide electrically isolated adjusts the transistor from one another. This specific technique is called local oxidation of silicon, and modern process using a superior technique that is called as shallow trench isolation, STO, grow thin gate oxide. So basically for that one, now we do the dopings and all of that stuff, right? We provide the isolation for each devices. Now what we do, you know that the structure of PMOS and NMOS is like this. This is, if I make a NMOS here, so we are having P type substrate, we are having a gate here, right? Inside the gate we are having a SiO2 layer here. After that we are doing the metallization here. So to make this gate, first what we do the SiO2 layer. We make a SiO2 layer here, right? So grow the thin gate oxidation, a very thin layer or high quality layer of SiO2, right, is thermally grow over the entire wafer, covering the active area, only that active area. Purpose the thin layer become a gate oxide and critically insulated layer of the transistor. Its quality and thickness directly control the transistor performance and reliability. Deposit and pattern polysilicon. Now after that what we do the SiO2 layer formation here. After that we will do the you can say the polysilicon gate. Basically generally inside the you can say the semiconductor, we don't use the metal part, we generally use the polysilicon. Polysilicon is a high conductive material. Its conductivity is nearly equals to the metal. So why we are decomposing the metal? Because the metal will provide you a, you can say, the difference between the properties of the semiconductor and metal. That's why we use the polysilicon gate here. Polysilicon gate is a gate of silicon, polysilicon, right? Polysilicon is a highly conductive material, right? That's why we provide the polysilicon gate here, right? The source and drain formation, after that we form the source and drain. So what we do the doping of N plus here. This is the part which will provide the isolation for your semiconductor. We do the doping here, P type doping, and this N plus, and this will be N plus polysilicon gate. Polysilicon means what? We are doing a heavily doped, very heavily doped N type semiconductor, because the metals are generally N type, right? So what we do, we just do the doping there, right? Dusting, annealing and drive-in. So another high temperature annealing is performed to electrically activate the implant dopant atom by moving them crystal lattice site and drive the junction to their final depth, so that they will go inside and they will be widely settled down there, right? Next is deposit space layer. A uniform layer of an insulator, often silicon nitrate, is deposited over the entire wafer, right? Each to form space, right? Next step, we will doing the etching to form spaces, right? And an anisotropic etching is performed where remove the insulating layer from the horizontal surface but leave it on the vertical side walls of the polysilicon gates. The purpose, these side wall space are critical for creating light dopant drain, right, structure, which improve the transistor reliability and reduce the electric field. And then silicide process, a metal like titanium, cobalt is decomposed deposited or reached with the silicon through annealing, right? Annealing is the process to doing that, right? It form a low resistance metal on the source and drain and gate region, and as metal unreached metal on the insulator like space is then etched away. So basically what we do the decomposition, or you can say the we do the depositing of titanium and cobalt on that part which is of your gate is not using, and rest of the part we will remove it. So what is the reason why we are using it? So that the resistance of the, you can say, the device drastically reduced, right? Reduce the electrical resistance of the source and drain and gate, which will improve the transistor speed, right? Transistor speed is basically depend on how fastly it will work in forward and reverse bias. After that we interconnect, depositing a interlayer dielectric so that two devices are separated from each other, contact etching and metallization. After that we are doing the masking and putting the holes, doing the metallization to make a metallic contact with the outer side. Low and final passivation for final low temperature annealing, ensure good ohmic contact, and we do that again, we heat up, and so that the contact between the metal, the outside metal and the semiconductor will be finished by doing this final annealing process, right? And this is the process how we can make that thing, right? Next, some questions are from there. Which process allow both NMOS and PMOS transistor to be fabricated on the same substrate? That is twin tube. Twin tube is the process to form both of them on the same thing, right? The main advantage of twin tube process is that independent optimization of NMOS and PMOS parameters. See, basically what we are seeing, we are having separate NMOS, we are having separate PMOS. So all the parameter of NMOS and PMOS are having different values. A twin tube process typically begin with, what is the first step? It is epitaxial silicon layer, and the process start with epitaxial silicon layer growth on the substrate, which provide a low defect and high quality surface for the further device fabrication, right? The P-wall in the twin tube process is used for, P-wall is used for making NMOS, right? Next is how are wall formed in the twin tube process? By using the ionic implantation, we do that one, right? Why are both N-wall and P-wall formed in twin tube process? To allow the NMOS and PMOS fabrication on the same substrate, right? So that we can make easily make the CMOS on the same chip. Which term is referred to a undesirable current path of CMOS circuit often address the twin tube process? That is latch up. Polysilicon is used in the twin tube process primarily for that gate electrode. To form the gate electrode we use that one, right? And some more questions are there. Let me check that one also. Yes. Next is, which step come first in twin tube fabrication? The first step is well fabrication. Which element is deposited for device isolation during the twin tube process? That is silicon dioxide, right, for making isolation. What prevent the latch up in twin tube fabrication CMOS process? That is epitaxial layer. Metallization in the twin tube process is used for creating the interconnection between the device. You can say it will create a connection between the means your NMOS or PMOS and the outermost device, right? Connecting lines, you can say. Wet oxidation in CMOS fabrication is primarily used to make a thick oxide layer. Which parameter can be independently optimized in twin tube technology? So basically that will be threshold voltage. I already discussed that thing, that the main advantage is that we are having two separate transistor and their properties are separate, means their threshold voltage and everything are different from each other. In twin tube process, which layer come immediately above the substrate? That will be epitaxial silicon layer, right? And which well accommodated PMOS transistor in a twin tube process? That will be N-wall, right? Yeah. The source and drain region in a twin tube process are formed by ionic implantation. Whenever you are doing the doping, that will be done by the ionic implantation. Independent control of NMOS and PMOS device property in twin tube process result in their high performance, right? So these are the some questions from this one. This is really important topic. Just go through this one. It will really help you. And If you want to prepare for this BEL exam, you can join Yourpedia. We already providing the live classes. I'm again repeating the same thing. See, this BEL exam is little bit, or you can say more easier from than the GATE exam, right? If you are thinking that your GATE exam, your GATE preparation is not that much good, you can go for this BEL exam. It is really good opportunity if you are from the electronics background, right? If you are from electronics background, you can go with BEL exam. If your preparation is not good for GATE, you can tackle this. If your preparation is good for GATE also, you can tackle this exam. It is a direct, you can say you are directly going into the PSU, and it is a permanent job. So if you want the permanent job, and this will not ask you that you have to be read day and night, you have to be solve more problems like that. It is only conceptual based exam, it is only theoretical exam, you can say. You have to be understand the things, and most of the theoretical questions are easy, very easy, but you have to cover wide of things, right? Which thing you have to cover, I will guide you. I will bring one more video that is related to syllabus of this electronics, right? What is the syllabus for electronics, where we should be more focused, that is based on the past exams which will be taken by the BL. I analyzed that and found that there are several topics which is not coming inside the GATE, and you have to be more focused on that one. So if you want to prepare for that one, you can join Yourpedia. Our online classes, or you can say the live classes, will going to be start on the 1st of November. So if you want that, you can surely want the selection on this one, you can join Yourpedia, and mentors will help you. Thank you.